Imagine a planet roaming the cosmos. Rogue planets are free agents, drifting through the... Instead of being gravitationally, could these rogue planets be home to forms of life? Of our universe, among the shimmering stars and spiraling galaxies, exists a peculiar type of planet, solitary and free. These are the rogue planets, celestial bodies that are through space, untethered to any star. Unlike our Earth, which orbits the sun in a predictable, yearly cycle, rogue planets are free agents, drifting through the dark expanses of space. These cosmic wanderers are a fascinating enigma, cloaked in mystery and intrigue. How do they differ from the planets we're familiar with, you may ask? Well, our understanding of planets has always been in the context of a star, a central point around which they orbit. We think of the 8 planets in our solar system, each following their own path around our sun. But rogue planets, they play by a different set of rules. Instead of being gravitationally bound to a star, rogue planets are like cosmic drifters, traveling through the universe on their own unique paths. They are the loners of the cosmos, the nomads of the night sky, the wanderers of the galactic wilderness. And while their solitary existence might seem a bit lonely, it's also what makes them so intriguing. What's their origin? How do they survive without the warmth of a star? And perhaps the most intriguing question of all, could these rogue planets be home to forms of life as we know it? The enigma of rogue planets challenges our understanding of planetary formation and survival. They present a puzzle that scientists are eager to solve, a new frontier in our quest to understand the universe and our place within it. So what are these rogue planets and how do they come to be? Let's delve into the depths of space to uncover their secrets. To understand rogue planets, we must first explore the birthplace of planets. Small part of gravitational tug-of-war between 2 massive bodies, a type of rogue planet that's somewhere between a planet and a nebula, a vast cloud of cosmic dust and gas. Within these nebulae, pockets of matter begin to clump together under the force of gravity, forming what we call a protostar. Now, around this protostar, a swirling disk of leftover material takes shape. This is the protoplanetary disk, the birthplace of planets. Small particles within this disk start to collide and stick together, gradually growing into planetesimals and eventually into full-fledged planets. But here's the twist. Not all of these planets are destined to live out their days circling a star. In the chaotic early stages of a solar system's life, gravitational interactions can get a little wild. You see, if a young planet strays too close to a larger sibling, or if it finds itself caught in the gravitational tug-of-war between 2 massive bodies, it can get a gravitational kick so strong that it's hurled out of its home system. Other rogue planets may have an even more dramatic birth story. Some scientists propose that these planets could form directly from the collapse of a cloud of gas and dust, much like a star, but without reaching the high temperatures and pressures needed for nuclear fusion. This process would give rise to what we call sub-brown dwarfs, a type of rogue planet that's somewhere between a planet and a star in terms of mass. And so these planets are set adrift in the vast expanse of space, becoming rogues. They're castaways, left to wander the cosmos without a star to call home. But far from being lonely, these rogue planets may just hold the key to understanding some of the greatest mysteries of our universe. And who knows, perhaps one day, we may even find that these nomads of the night sky are not as barren and desolate as we once thought. Now that we know how rogue planets are formed, we think of survival on Earth. These bodies are not cataclysmic events of cosmic proportions that could potentially support subsurface oceans, waiting to be unraveled, without a star to call life of a rogue planet. Like celestial nomads, they roam the galaxy, not bound by the gravitational pull of a star. But how do they survive in the harsh environment of space without the warmth of a star? Well, they don't need to survive in the way we think of survival on Earth. These bodies are not living organisms. They don't require sunlight or warmth to exist. They simply are. Rogue planets could follow various paths after being ejected from their star system. Some may continue to drift in the interstellar medium, the space between the stars, for billions of years. Others may get caught in the gravitational pull of another star and end up in a new star system. Some could even collide with other celestial bodies, creating cataclysmic events of cosmic proportions. The life of a rogue planet is not an easy one. They are subjected to the full brunt of cosmic radiation without a protective magnetic field like Earth's. They are also incredibly cold, with surface temperatures that can drop to -270 degrees Celsius, nearly absolute zero. But despite these harsh conditions, rogue planets are not devoid of activity. They can have geologically active cores, creating internal heat that could potentially support subsurface oceans. Rogue planets are the embodiment of resilience. They withstand the harshest of conditions, persisting in the face of unimaginable cold and isolation. They are a testament to the enduring nature of matter in our universe. It's a lonely existence, to be sure, but it's also one of profound significance. Rogue planets challenge our understanding of planetary formation and survival. They remind us that the universe is full of mysteries, waiting to be unraveled. Without a star to call home, these rogue planets lead a solitary existence in the cold, dark corners of the universe. Rogue planets, by their very nature, are elusive, yet deeply rooted in Einstein's theory of general relativity, often lasting just a few hours, slipping through our observational net. Understanding and ability to detect rogue planets is improved a variety of techniques to detect these elusive worlds, and one of the most effective methods is known as gravitational microlensing. Now, gravitational microlensing might sound like a phrase straight out of a science fiction novel, but in reality, it's a concept deeply rooted in Einstein's theory of general relativity. According to this theory, massive objects like stars and planets can bend and magnify light. When a rogue planet passes in front of a distant star, it can act as a lens, magnifying the star's light and causing a brief, noticeable brightening. This brightening event, or microlensing, is what astronomers look for when hunting for rogue planets. But it's not as easy as it sounds. These microlensing events are rare and fleeting, often lasting just a few hours, and they don't repeat, making them incredibly difficult to study. Astronomers have to be in the right place at the right time, looking at the right part of the sky. There's also the issue of size. Larger rogue planets are easier to spot because they cause more significant microlensing events. Smaller planets, on the other hand, can easily go undetected. This means that while we have found a handful of rogue planets, there could be countless more out there, slipping through our observational net. But don't let these challenges discourage you. The search for rogue planets is far from a hopeless endeavor. With advancements in technology and observational methods, we are getting better at spotting these elusive worlds. Space telescopes like the upcoming Nancy Grace Roman Space Telescope are set to revolutionize the hunt for rogue planets, with the potential to spot thousands of these wandering worlds. Despite their elusive nature, our understanding and ability to detect rogue planets is improving with every passing year. One of the most intriguing questions about rogue planets, cold and darkness of space. Firstly, let's, in the form of vast subterranean oceans, source to maintain a consistent environment. Perhaps one day we'll discover that we're not alone in the universe. Stand it, certain conditions are needed. These include liquid water, a source of energy, and a stable environment that can maintain these conditions for billions of years. But how could such conditions exist on a rogue planet, drifting in the cold and darkness of space? Firstly, let's consider the role of heat. Without a star to provide warmth, you might assume rogue planets are icy wastelands. However, when these planets are formed, they retain heat from their creation. This internal heat, escaping from the planet's core, could potentially be a source of warmth. But what about water? On Earth, we're used to the idea of water coming from rain, rivers, and oceans. But on a rogue planet, water might exist beneath the surface, in the form of vast subterranean oceans heated by the planet's core. In fact, we've seen this in our own solar system, on moons like Europa and Enceladus, which harbor oceans beneath their icy surfaces. And finally, what about stability? This is perhaps the most challenging condition for a rogue planet. Without a star to anchor its orbit, a rogue planet's environment could be subject to extreme changes. Yet, if the planet is large enough, it might have a stable enough internal heat source to maintain a consistent environment. Of course, these are all theoretical possibilities, and the reality could be very different. We're still in the early stages of understanding rogue planets and the potential they hold for life. But as our knowledge expands, so too does the scope of our imagination. While the chances might be slim, the possibility of life on rogue planets is a tantalizing prospect that continues to captivate scientists. And who knows, perhaps one day we'll discover that we're not alone in the universe, and our first contact might just be with a rogue planet, adrift in the depths of space. With the continuing advancements in space technology, an even clearer view of the cosmos. Rogue planets like never before, potentially unveiled like CubeSats, opens up a wealth of opportunities, and of subsurface oceans, a possible haven for. It's a thrilling era, where our curiosity about these celestial nomads is matched only by our technological prowess to explore them. In the near future, the next generation of telescopes, both ground-based and in space, will provide us with an even clearer view of the cosmos. These technological marvels will be equipped with the ability to detect the faintest light from rogue planets, enhancing our capacity to discover and study these solitary wanderers. One of the most exciting developments on the horizon is the launch of the James Webb Space Telescope. It's anticipated to revolutionize our understanding of the universe with its unprecedented ability to detect infrared radiation. This will allow us to observe rogue planets like never before, potentially unveiling worlds that have remained hidden in the darkness of space. In the realm of space travel, developments in propulsion technology are making the dream of sending probes to rogue planets more feasible. Concepts like nuclear propulsion, ion drives, and even theoretical warp drives could significantly reduce the time it takes to reach these distant worlds. Furthermore, the development of miniaturized, cost-effective spacecraft like CubeSats opens up a wealth of opportunities. These small yet powerful explorers could be dispatched in large numbers to investigate multiple rogue planets simultaneously, increasing our chances of making groundbreaking discoveries. But it's not just about the hardware. As our understanding of these planets evolves, so too does our strategy for exploring them. Future missions will likely focus on identifying signs of geothermal activity, which could indicate the existence of subsurface oceans, a possible haven for extraterrestrial life. As we continue to push the boundaries of our knowledge and technology, who knows what secrets these rogue planets may reveal. With each passing day, we're getting closer to answering some of the most profound questions about our universe. The future of rogue planet exploration promises to be a journey filled with wonder, discovery, and perhaps a few surprises along the way. We've journeyed through the birth, life, and future prospect cradle of a forming star system. During radioactive decay or tidal forces, worlds seemingly inhospitable on their surface detail, providing insights into their composition. Rogue planets remind us that the universe is full of worlds, untethered from the gravitational pull of a parent star, roam the cosmos in solitude, their mysteries concealed in the inky blackness of space. We've learned that rogue planets are often born in the chaotic cradle of a forming star system. During these tumultuous beginnings, gravitational interactions can fling a young planet out into the galaxy, severing its celestial umbilical cord. Thus, a rogue planet embarks on its solitary journey. Their lives are as fascinating as their birth. Devoid of a nurturing star's warmth, rogue planets are not the barren, frozen wastelands one might expect. Beneath their icy surfaces, these wanderers could harbor vast oceans, kept warm by the heat of radioactive decay or tidal forces. The search for these elusive entities is no less compelling. Astronomers use ingenious methods, like gravitational microlensing, to detect the subtle influence of a rogue planet's gravity as it passes in front of a distant star. This cosmic sleuthing is like trying to spot a mosquito flying past a distant lighthouse, a testament to the ingenuity and determination of our scientists. And what of extraterrestrial life? Could these wandering worlds, seemingly inhospitable on their surface, harbor the conditions necessary for life? The possibility is tantalizing. After all, life on Earth began in the depths of our oceans, shielded from the sun's harsh radiation. Might the subsurface oceans of a rogue planet provide a similar refuge? The future of rogue planet exploration is as vast and unknown as the universe itself. New telescopes and technologies may soon allow us to detect and study these nomadic worlds in greater detail, providing insights into their composition, atmosphere, and perhaps even signs of life. In conclusion, rogue planets present a fascinating study in contradiction. They are at once familiar, resembling the planets of our own solar system, yet utterly alien in their solitary existence. Their study challenges our understanding of planetary formation and survival, and tantalizes us with the possibilities of life beyond our starlit shores. As we continue to explore the cosmos, rogue planets remind us that the universe is full of surprises, waiting to be discovered. The enigma of these wandering worlds continues to captivate us, drawing us ever deeper into the mysteries of the universe. Before we end this cosmic journey into the unknown, comments. Your opinions and insights are as we unravel the mysteries of the cosmos, we're reminded that your engagement helps us continue to explore and share the wonders of our universe. Do rogue planets fascinate you as much as they do us? Perhaps you have your own theories about the mysteries they hold. Maybe you're skeptical of the possibility of life on these wandering worlds. Whatever your thoughts, we encourage you to share them in the comments. Your opinions and insights are a valuable part of this cosmic conversation. And if you've enjoyed this journey, don't forget to subscribe for more such content. As we continue to explore the final frontier, we'll bring you more videos about the mysteries of our universe, from the smallest particles to the largest galaxies. Finally, if you know someone who might be intrigued by the enigma of rogue planets, share this video with your friends and family. As we unravel the mysteries of the cosmos, we're reminded that we're all part of this grand cosmic story. So let's explore it together. And remember, the universe is full of surprises, waiting to be discovered.